This is Unit 12, Lesson 8, Part 1. We are going to be learning how to graph sine and cosine functions in this video. The next one we'll do tangent, and then in the third part we will move on to the reciprocal functions, secant, cosecant, and cotangent. So the main ones that we are going to be working with are sine and cosine. So first, just a quick little introduction to what it means to be a periodic function. So the definition we have here, periodic functions are functions that repeat exactly in regular intervals. So there are these things called cycles where it repeats the same cycle, the same values over and over and over again. So trig functions are periodic. They repeat the exact same values over and over because they're based upon the unit circle. And the unit circle just goes around and around over and over again, meaning the sine and cosine values repeat themselves over and over again. Two quick definitions we're going to be using for the next 3 or 4 lessons. Very important here. The period is how long each one of these cycles is. It goes around and it finishes, that's one period. It goes around, it finishes again, that's a second one. So the length, so going from like the beginning to the end of the cycle, we call that the period. Okay, so this is where the cycle starts, it goes down, it comes up, and then this is where it starts to repeat itself. So this length is known as the period. The amplitude, think of it as almost like the height of one of these waves right here. So we've got this midline that runs right through the whole thing. The amplitude is this distance. So from the midline up to the top or from the midline down to the bottom. So that is known as the amplitude. We will be using both of those vocab words a lot, and we'll also be learning how to calculate them with the given graph that we have. All right, so here is just the original graphs for sine and cosine, y equals sine of theta, y equals cosine of theta. I'm going to reference the unit circle as we go back and forth between these two graphs. So remember, theta is the angle. We're going to be doing entirely radians as we work with this, and I'm going to be using our unit circle and kind of putting it back and forth onto the screen. So all radians all the time now, you will see these measurements are theta. So this axis is theta instead of x. So we have 0, pi over 2, pi, 3 pi over 2, 2 pi, and then we have the negative angles. These are the y values going up here. So remember, the original sine always goes somewhere between -1 and +1. So this one, we're going to start with 0. So the sine of 0, here's 0 radians, sine is the y-coordinate. So the sine of 0 is 0. So we start right at the origin here. And then if we move to pi over 2, the sine is the y value, so that is 1. So sine of pi over 2 is 1. And then pi, so sine of pi is 0. 3 pi over 2, sine of 3 pi over 2 is -1. And then 2 pi is back where we started, the sine is 0. So that is one cycle, that is one period of the sine graph. It goes from 0 to 2 pi, so the length of the whole thing would be the period, and that is 2 pi. The amplitude is just how high the high point is, how low the low point is. That is just one unit in each direction. That's the amplitude. So then it repeats itself. It goes all the way to the left, all the way to the right. So you can see this cycle just kind of reverses as we go back in this direction right here. Okay, so it just goes up and down in these kind of wave-like motions here. Just keeps repeating itself many, many times to the left and to the right. All right, so now let's look at a cosine graph. So starting at 0, remember if we look at the unit circle, cosine is the x-coordinate. So the cosine of 0 is the x-coordinate, which is 1. So cosine of 0 is 1. Then move to pi over 2. Cosine of pi over 2 is 0. Then pi, cosine of pi is -1. 3 pi over 2, cosine of 3 pi over 2 is 0. And then 2 pi, we finish where we started. Cosine of 2 pi is 1. Okay, so that is one cycle. Starts up at the top, goes down to the bottom, finishes up at the top. Same exact length of that cycle. The period is 2 pi. Same minimum and maximum points. We go up 1 unit, down 1 unit. That means the amplitude is also 1 for the cosine function. So then you see this pattern just repeats itself as you go back to the left-hand side. If you were to expand this out, that pattern would just keep repeating, just going up and down and up and down. So it looks really, really similar to the pattern of the sine function. The difference is where it starts. This one starts at the origin, this one starts up at its high point. But then that cycle just repeats itself over and over. So that's what the original sine and cosine graphs look like. For the rest of these notes, we're going to be learning how to transform them. We're going to transform the period, which means making them longer or shorter. We're also going to be transforming the amplitude, which means making them higher or lower on the y-axis. All right, so we have this value of A, this value of B that we can put into our trig function. The amplitude is just whatever A is. So we're going to put it within an absolute value because we will get to a point where A might be a negative number. So you just want to make sure that you're counting the amplitude as being a positive value. The period is originally 2 pi. So like this period is always 2 pi. And then whatever you have here, you divide by that value. So you have 2 pi, and then you divide it by whatever is in front of the theta, which is B. All right, so 2 pi divided by B. And so this one, like there is no B right here. So 2 pi divided by 1 just means the period is 2 pi. So what this value actually is, this letter of B, is how many cycles in 2 pi, or 360 degrees, but we're trying to get used to radians here. So this goes through one cycle in 2 pi. If you were to put a 2 here, if you were looking at a distance of 2 pi, it would go through 2 complete cycles. So it would go twice as fast. All right. So now we are going to work through some different transformations that we can make. So starting with number 1, we're just going to go through and work on all of the odd functions. So this one, identify the amplitude and the periods. The amplitude is just this number right here, the absolute value if you need to, if it's negative. So the amplitude is 3. So that means if we were looking on this graph, instead of this high point being at 1, it would be all the way up here at 3. Instead of the low point being -1, it would be all the way down here at -3. So it stretches it out quite a bit, makes it taller, makes it lower. That's what the amplitude does. The period, you take 2 pi and then you divide it by whatever's in front of the theta, which is 2. This means we go through 2 complete cycles every 2 pi on your theta axis. So this reduces down to pi. So this, instead of taking all the way from here to here to go through 1 complete cycle, it would only be from here to here. So it would move a lot faster. It would go up and down before it even got to pi. And then it would go up and down again before it got to 2 pi. So that means it would go through 2 complete cycles in this length right here. All right, our next page, we are actually going to do some of those graphs. Okay, so starting with number 3, we're still going to identify the amplitude and the period, but then we're actually going to graph those functions. All right, so this one, this number right here is the amplitude. So it's going to go up 4 units, down 4 units to get to its high and its low point. There is nothing right there, so the original period is just 2 pi. All right, so watch what we do here. I'm going to compare it back to the original sine graph. So the original sine graph, it begins at 0, it ends at 2 pi, okay, because that's the cycle length. This one is going to do the same thing. It's going to begin at 0, it's going to end at 2 pi, because that's still the cycle length. Now, it's going to go up 4 units, where this one previously only went up 1 unit. Okay, so at pi over 2, instead of being at 1, it's going to be all the way up here at 4. At 3 pi over 2, instead of being at -1, it's going to be all the way down here at -4. Okay, so for my first spot, I'm going up 4 units. For my third spot, I'm going down 4 units. And remember this middle point, which is kind of right here. So that is one cycle. You extend it, just kind of repeat it going backwards in the other direction. So that would look like this. Okay, and then just keep that cycle going. We go up, we go down. Repeat it just over and over and over again. Okay, so that is our first trig graph. Looks like a wave, kind of up and down. This tells you how high and how low it gets. This tells you how quickly it moves through its cycle. All right, next on number 5. This number right here out front is the amplitude. If there's nothing there, you assume that it's 1. Like let's say we had done number 4, that amplitude would be 1. 3 pi right here. So we take 2 pi and we divide it by the 3. That's right there. All right, so our cosine graph, let's look at that pattern. It starts its cycle up at the high point. All right, so the high point here is 1. The high point here is only going to be 1/2. So we go just half a unit up, and that is where we start our cycle. It's going to end our cycle 2 pi over 3 units later. Okay, so that gets a little bit tricky. So 2 pi over 3, we've got 1/2. This is 3/4 right here. So 2 pi over 3 is going to be somewhere in the middle. All right, so this is 1/2, this is 1, so 2/3, just kind of do your best and approximate. It's going to be right around there. Okay, so a cosine graph. It starts at its high point, it ends at its high point. In the middle, it's down at the bottom. Okay, so if this is 2/3, then at 1/3, it's going to be down at its low point right here. All right, so that's going to be right around there, kind of halfway in between. And so you can see that's what one of these cycles looks like. It moves through its cycle very quickly. All right, so then just repeat it. Just go up and down. So then 4/3, it would finish another cycle. So that'd be right around there. So you can go up and down again. And then at 6/3, it would finish another cycle. So this should be at 6/3. It should be finishing its last cycle. So I think I did that one not quite far enough. Sorry, if this is 2/3 right here, then 4/3 would be 1 1/3. So that should be right around there. So start and end a cycle here. Start and end a cycle here. And then you can kind of go backwards in the other direction, just repeating. So negative 2 pi over 3 would be right around here. Negative 4 pi over 3 would be right around here. And then this is where it ends for real. Okay, so kind of work your way backwards, just going through these cycles like that. All right, 2 more examples, keeping with these odds. This one, there's nothing out front, so the amplitude is 1. It goes up to 1, goes down to a -1. This one, 3/4. We can take 2 pi and divide it by 3/4, which is the same as multiplying by 4/3. So if I take this times 4/3, I end up with 8 pi over 3. All right, so 8 pi over 3 is my period. So cosine graph, just remind yourself, it starts up at its high point, ends at its high point. So its high point is just up at 1. So it starts the cycle at 1, and then we have to see where we're going to end it. So 8/3. 8/3 would be a little bit past this, because remember, this is 6/3. So 8/3 is going to be farther out here somewhere. So we can expand it just a little bit, and then it'll be halfway through its cycle at 4/3. All right, halfway through its cycle at 4/3. So that would be right around here. Okay, so it's up, it's down, it's back up again, and that's where it's going to end its cycle. And then you can repeat yourself back in this direction. Okay, so that looks like that. One last graph here, number 9. The amplitude is 3, so it's going to go up to a high point of 3, down to a low point of -3. And then the period, you take 2 pi and you divide it by this number here, which is 2. So this reduces down to pi. Okay, so high point and low point are going to be up 3, down 3. The period is just going to go from 0 to pi. So let me refresh your memory on sine. The cycle starts at 0 and it ends at 0. Okay, so the cycle starts at 0 and then it ends at 0. So it's going to end at pi. Okay, then remember, the middle of its cycle is also at 0. So see, it goes up, goes back to the middle, goes down, back to the middle. So beginning, middle, and end is all right on the axis here. So here's beginning, middle, and end. It goes up to the high point, which would be up to 3, and it goes down to the low point, which would be down to -3. Okay, so that's one cycle, and then we just repeat as many as we need to. So high point, middle, low point, middle, high point, and then if we do it backwards, it goes low point, middle, high, middle, low, middle, high, middle, and then just go up and down. So the pi made these cycles go much, much shorter And the 3 made these cycles go much, much taller. So this is going to look quite condensed compared to how our original sine graph looked.